Hello everyone, in this video we are following chapter F4.9, exploring lag effects and time series from the book Cloud-Based Remote Sensing with Google Earth Engine. We will follow the fourth section of this chapter and try to understand autocovariance and autocorrelation, and we will also check the codes very briefly. Time lag effects are the effects when an event at one point in time impacts dependent variables at the later point in time. Autocovariance of the time series refers to the dependence of values in the time series at time t with values at time h equal to t, where h equal to t minus lag. And here the lag is the difference between these two times. The autocorrelation is the correlation between elements of the dataset at one time and elements of the same dataset at the different time. The values of the autocovariance are positive, negative, or 0, and the values when positive indicates that the variable tends to be higher or lower at one point in time if it was higher or lower at the previous point. If the temperature today is higher, when the temperature yesterday was higher, then here the autocovariance is said to be positive. That's the example. And negative autocovariance is just the opposite. The values are inversely related. For instance, if the temperature today are high, but yesterday's temperature was very low, then there is the negative autocovariance. And the zero autocovariance is when there is no systematic relation between the values and the two different points. Autocorrelation is just the same. Positive autocorrelation means variables are similar to itself with the previous or future times. Then we have the negative autocorrelation, where the values are just the opposite between the two times. And zero autocorrelation means there's no predictable pattern in the values. So these are the concepts of the autocovariance and the autocorrelation. We will briefly check the codes. These are not that difficult. We begin with the this function to mask the clouds, and we also scale and we add the variables to the Landsat imagery. So we calculate the NDVI, we add the time band, and we also add the constant band. So this is the function for that. And then we have the region of interest, that is somewhere in California. Here we are filtering the image collection by the region of interest, filtering it with dates, and mapping the function where we add the variables. So the variables of interest are this NDVI band, time band, and then the constant band. And we want to work with the trended time series, and this is done by eereducer.linear regression, where it takes the independence and dependence value, and from that output trend image, where we have the coefficients and residuals. We use that to detrain the series. Just applying the normal function, we are selecting dependent and then subtracting the independence and multiplying it with coefficients, and finally reducing to get the sums. And this detrains the series. And for the autocovariance, we want to compare the values at time t to the previous values or the future values. So there is some gaps of time periods between two images, and this is required, or this is done when we have the elect collection. So here we have the join function to create this collection. So it is just joining the collection by itself. So we will have first image now, and then we will have some certain time time gaps, and then we will get the new image. So we will get these two images. And here the images are stored in this property, and these are reversed chronologically. So we will get the new image at first. And what we get here is the lagged image. You can see we are using this for the same image collection. And if we print this and see what really is inside this, you can see we have the NDVI here. And inside the properties, we have the images, and that is the band NDVI. So this is the lagged. This is named as lagged 17. Then we have the function to stack the bands. And what it does, it just gets that images that was in the properties here. And this will just merge the two bands. Let's see what is happening here in merged 17 variable. We have the two different NDVIs. So this is the first NDVI, then we have certain time gaps, and then we get the new NDVI. So this is what the join function is doing here. And then we compute the autocovariance using this reducer function, that is ee.reducer.covariance. So it requires the one-dimensional array as the input. So the two bands here, images are the two bands. The first band and the like band is converted to the array image, and this is inside the same image. And then we also we are just preparing this as the function and apply this to that image collection where we have the two different bands, and our dependent is the this _1 NDVI, and then we also have the lag band as NDVI. Sorry, so the lag band is the NDVI with _1, and then we also have the NDVI as the dependent band. So what we get is the 2x2 covariance array, and the diagonal elements are covariance. So basically we are doing the covariance, and covariance just tells if when the one value is increasing, does the other values, the other one increases or not. So this is the covariance. And eventually we do the correlation function. Here we are dividing that covariance with the two different standard deviation. So if we look into the matches, it's just applying the formula of correlation. And here we are adding the correlation in the image as the image, and we're also adding another layer, that is the covariance. So these are two layers here. So what we did is just we degenerate the series by linear regression. We joined with itself. We joined the image collection with itself to get the first band and then the lagged band, and then we converted the images into arrays, and after that we just applied that reducer.covariance function, and what we get is the 2x2 variance covariance array, and then we did the correlation, that is the autocorrelation here. So I hope this was helpful. This was the gist of this first section. And again, what it says is all about the arrays and to be able to work with the array images. So this is the main thing here. Anyway, I hope this was helpful to you. Please comment if you like. Thank you for watching.